So I'm using Microsoft Excel in this example, and what I'm really doing here is I'm going to work through investigation 1. This is on page 382, and we'll use the data set which is on that page. So here I put in my data. The first column here is the amount of nutrients, and the second column, or the second variable, is the area covered in mold. So this is mold growing in different petri dishes with different amounts of nutrients. And the area of the dish covered in mold after 48 hours is recorded. So this is the area, and this is the amount of nutrients that these bacteria or mold are getting. So we can start off by drawing this in a diagram. Just mark the data you have. Now, if it fails with a full stop, try a comma instead. I think you might be able to set up that differently, and Excel is going to read it one way or the other. So diagram, we want a scatter diagram, and this is where you find the scatter diagram. So put in and then scatter diagram like this. Okay, we just move our diagram down here. We could have a quick look at it. It's okay. You can see this snake going up. So it's not a very good linear correlation, but we're going to check what the linear correlation would be. So we'll start by calculating the Pearson's correlation coefficient, and to do that, we say that our R is equal to, and then we put in this formula here. Correlation. Let's just see what that. We could just see what that is in English. If you're using the English version of Excel. Now, if I hang on, yeah, we'll just mark the area first, semicolon between here, and then just drag down this second variable. So this is how you put in the data. So we have correlation of 0.96. Now I just wanted to translate this bit here. If we go to translate here, okay, so we're translating from Norwegian to English, and if I write correlation, it's going to say correlation here, right? If I paste in the whole thing, you can see that in the Norwegian formula there is a semicolon, whereas in the English formula it's a simple comma. So it's important to make these distinctions. Okay, so but this is the Norwegian version, so we're using korrelasjon. Okay, so you can see it's a fairly strong correlation. But we're going to look at the Spearman rank correlation and see how that compares. So we're all set up here, and now we found the Pearson's correlation coefficient, which was 0.96, which is fairly strong, and now we're going to find the Spearman's rank correlation coefficient. And we start off by finding the okay, if we look at this list of data here, we're going to rank these numbers in terms of size. So instead of duplicating the raw data itself, we're giving the rank the order of the numbers as they sit here. from the highest to the lowest. So we start with the highest number, which is going to be number 1. But we can do this automatically in Excel. So we're going to make the spreadsheet do the calculation for us. We do that by putting in the formula, so equal sign, rank average. In Norwegian, it's going to be this one here. This one. And so we want to see which rank does this number have, this cell, 5.68, which rank does it have in this reference area here. But we're going to have to put in these dollar signs to make sure that the reference area does not change, even though this this cell is going to change. So the first cell is A5 and then A6, A7. Okay, so this is how the formula is going to look like. And the next bit, do we want an ascending or descending order? So we want an ascending order. So we'll put in a 0 like this. Okay, that's our formula. We're going to do the same thing for the second column here. So we can just copy paste this onto the next. Oh, no, that didn't work. That didn't work because we've locked this cell to the A column. So we're going to change that to B, like this. Okay. And that's going to be in descending order as well. So the first numbers in this data set. So 5.68 is ranked as number 3 in this reference area. And the area covered in mold equal to 6 is also ranked 3. Now, if we copy these all the way down, you can see that they have the exact same values, actually. So they are ranked exactly the same. Now, if we wanted to put in the English formula for this, we'll just do that as well. So we'll just copy that bit and go to data, look through, and then translate. And we're going to put in the Norwegian formula here. And you can see that it translates that as rank dot average. Now, if you look at this more detailed, you can see the cell here, you can see the reference area here, and then at the end here, rather than a semicolon, there is a full stop in the English version. So just be careful with that if you're using the English version of Excel. So we have the ranks. In this column here, we're going to take the difference between these two cells. So equal sign, and that's simply going to be this cell minus this cell. That's 0. And I mean, no surprise here, but since all these values are the same, the difference is going to be 0 all the way down here. Finally, we're going to square the difference. So this number multiplied with this number itself. Yeah, that's going to be 0 as well. And we copy that down. And we are going to sum up all the numbers. Sum up all the differences like this. And that's also going to be 0. So what we have now is the sum of differences between the ranks of the values in the two data sets. Now this formula down here, this is the R, this is actually an R, this is rho in Greek, so it's an R. So this is our Spearman's rank correlation coefficient. And we find this by subtracting this fraction from 1. And this is 6 multiplied with the sum of differences squared divided by n, and then you have n squared minus 1 in parentheses. Now, the textbook makes the mistake of not generalizing this formula. So there's a terrible mistake on page 380, which is relevant only for the example you have on that page. So we start by multiplying this sum of squared differences with 6. So we're going to take this cell here and we're going to multiply that with 6, which is 0. Then we're going to divide it by what we have under the fraction here. First of all, we have to work out what n is. And n is the number of data pairs that are compared here. So the number of square differences. And we can do that by using this formula, number Montal. So we want to know the number of values in this reference area here. And the number of values is 8, so it returns the value 8. Now in English, if we want this formula, translate count. So yeah, write count. Yeah. Okay. So now we take our product here, we multiply it with 6, we take that number and we're going to divide it by n multiplied with n squared. We can just multiply it with itself, minus 1. So just be careful with the brackets, the parentheses here, and you'll be fine. And that's going to be 0, 2. And this last bit here is to subtract everything from 1. So 1 equal sign 1 minus this equals 1. And as you can see here, you have this is our Spearman's rank correlation coefficient. Here it was 0.96, here it is 1.0. So here we have a perfect correlation between these two variables. And this is because this is not a linear correlation, so you wouldn't get a perfect correlation using Pearson's. But when we use Spearman's, we are comparing the ranks of the data sets. And then we do actually get a perfect correlation.